Hey guys, so basically, I'm back again this week. This is actually the last session that we're gonna have before I go on a trip next week to Philippines. So basically, back to the topic of learning electronics with Adept Studio's electronic kits. What I have here is actually some of the items that are already out of the box with the Ultimate Starter Kit for Arduino by Adept Studio. Um, I do have the link in the previous video, so I'll probably just copy it in the description after this session. But you can go to that video and look at the link and get the kit from there as well. All right, so the whole idea about having this lab series, if you are just watching this for the first time, is really about trying to share with everyone in the world about like what are the best electronic kits in the world, as well as beyond the basics of what the electronics kit is teaching you. What sort of things can you do with what is available. So that's basically the whole idea of having this lab series. And this lab series, like what you are seeing here, I am actually working on a particular project right now. It's just a very early basic prototype idea that I'm trying to build to perhaps evolve one day in the future sessions into maybe a project that you can implement in your own home as well. So what you see here is actually this cardboard box is from Sentech. They basically shipped me some product samples, and then I just got to opening it today. So I thought, hey, why not make use of the box that they have given to do something, right? So basically, what you see here is that I actually have the servo motor that I've attached to the side of my cardboard box. All right, so you can use any kind of cardboard box that you have, as long as there's a lid and so on, and you can simulate the open and closing. It's like a lever, right? So let me just try and focus so you can see better. Okay, let me shift my things. Okay, so basically I have this lever as well as this little the part that is I glued it to the servo motor so that when it turns, right, when it turns in the degree, it will actually adjust the lid to open up. So I actually had a video that I shared on social media earlier today that shows it working, right? But don't worry, later you get to see it working as well. So the whole idea is that I wanted to include a proximity sensor. So in this case, for example, the proximity sensor will be right in front of the box, and it will actually detect like the distance, how close is it, how far is it from the box itself, and it will automatically trigger the box to open. So clearly, you can't use this in a real world project. So I mean, who uses proximity alert to open a box, right? So, but yeah, this is based on what is available in the kit, and it's just an idea, a prototype that you can create to simulate certain ideas. And the whole point of doing this also is to encourage you guys to be creative. Now, from my experience, I was pursuing my passion in IoT electronics for the last few years, and being pursuing a passion and interest is honestly not easy, and sometimes financially it's not stable. So in the process of pursuing my passion, I sort of have to learn to make do and make the most of what I have, even though I have very limited budget. So stuff like using cardboard boxes and cutting them up and actually basically making basic moving objects, engineering concepts. I do all that with cardboard boxes, and that's how I actually learn and experiment. So honestly, learning electronics and working electronics, you don't really have to spend a lot of money. All you need to do is just have some creativity and some crazy ideas, and you can actually do a lot of amazing things with it, right? So basically, this part of the video, earlier today I've already sort of got the motor to work, so that is already working fine. The only thing that I have not implemented yet is the proximity sensor. So this session, you're going to see me work on the proximity sensor uh, portion of it, all right, and then integrating together with the uh, integrating with PlatformIO. So anyway, it's probably good to note that if you are watching this video, I would assume that you are one of the two groups of viewers. One, you are probably somebody that has worked with the kit before. Right, so you can see that the box is opening and closing on its own. So that's the idea. But now it's just opening and closing every 3 seconds. So I want it to be more automated, and basically, it will only be triggered to open when something is actually close enough to it. So I am going to screencast over to the IDE, right? I'm basically using the Atom IDE together with PlatformIO. And that is actually the IDE that I would recommend you guys to try it out, because it has a lot of the IntelliSense involved. IntelliSense meaning as you type and you put the period to load the say the attributes or the properties of a particular class, it would actually list out the relevant methods for you to pick from. So it's a lot easier to work with as well, right? Definitely very good for beginners as well. I mean, you can use Arduino IDE, that's for sure. All right, but I use this IDE more than anything else. So let me just load it up. Okay. Okay, so I'm just gonna unplug this so the sound will start making a noise. Okay, so I know the font might seem a little bit small, so I'm just going to enlarge the editor's font in a moment. Okay, let's make it much bigger. Okay, I'm just going to see. Okay, so basically, I have the platform IO open. This is actually what I've created earlier this afternoon, which is the servo portion. So you can see that I've actually set the first right to 170 degrees. So that's actually the degrees that I wanted the opening lever to rise up to, right? So it basically lifts the lid of the box up far enough to sort of make it fully open. Okay, so the next thing that we need to do now is to work with the proximity sensor. So I do have the coding for the project. So it's always good. I kind of like to do it this way. It's not that I'm lazy, but I think it's a lot more effective to just copy and paste sometimes. Do they have the? Hmm. Okay, there's no proximity. So let's go to PlatformIO's libraries. I will put all the download links in the description after the session. So if you are watching this as a rebroadcast, you'll be able to get access to those links and download the relevant IDEs, PlatformIO, all right, as well as to get a kit. All right, so don't worry about that. I will provide all of that in the description. Okay, so let's look for proximity. Um, hmm, proximity sensor. Okay, so let me just. Okay, so basically I did, one thing I like, that's what I like about kits, learning kits that have the book, all right? So with the book, it's a lot easier to sort of look for what you're trying to learn and so on. So I am going to try and find let me focus. Okay, I think there is a exercise in here that talks about the proximity sensor. I can't remember which lesson is it. Let me see. Ultrasonic. Hmm. So I clearly have no idea where the lesson is. I haven't got to that lesson in this booklet. Okay, I found it. Yes. So basically, it's in lesson 19. All right. So lesson 19 has the exercise for the ultrasonic distance sensor. So it's really good, and I'm just gonna go over to the repository and copy it over and open it in Arduino IDE. Okay, so mm, so you can see from here the directions. All right, let me just bring it up. Okay, I'll try and make it clear on the webcam so you can see it. Okay, so basically, I know I'm trying to focus. So basically, here we have the, based on the pins, you can see from left to right. From left side is actually the uh, source voltage, all right? Then the last one is your ground. Okay, and then the middle two pins basically goes to pin 5 and pin 7. So that's what we're going to do right now. Okay, I have this, and I've got a bunch of wires. I know it's very messy, but I always keep them around, so when I need it, I don't have to just take it out the box again. I can just use them. So the color doesn't really matter. So we're just going to plug in this, and then, well, if you want to use color coded, follow the exercises, that's fine as well. Um, but yeah, as you get more seasoned with working with electronics, it tends to get much easier. So now I'm just trying to find the right socket to use, or the right wires to use. So in this case, it's good to know that you need to have female to male. Now, within the Adept Studio's Ultimate Starter Kit for Arduino, they do provide male to female, which is really good. Most starter kits I have bought and experienced before, they only have male to male. So that is a bit of a limitation. Okay, so we are going to put this in. Let's use gray for. Okay, so basically I've put in wires. Um, I guess I have to reuse my breadboard from the last. Oh, actually, I have extra breadboards. So this is what I've learned. Always have more than enough breadboards because there's always never enough. The good thing about the sensors kit by Adept is that they do provide a medium-sized breadboard, which is awesome. All right, so we're going to use this. If you're interested to know what's the code for the sensor kit, I'll put it in the description later as well. So you can go and get it. All right. Okay, so let's open this up and use our new. Okay. Okay, let's remove the wires. Okay, so once we are done, we need to put the voltage into. Actually, you can just pin it on the breadboard, but because I want to sort of put it outside the box, so I thought using the wires would be a lot better. So gray color, my gray color is to ECC. All right, so I'm gonna just move it down and see. Okay. I'll probably need to focus the camera. Okay, so from the VCC of the proximity sensor, we will put it into the positive railing, then ground to ground, and then um, TR IG, I think TR1G. It will go into pin 7. Okay, so this blue one, the second pin. Okay, the second pin, let me just try and bring it under the camera for you. Okay. The second pin will go into pin 7, and the third pin will go into pin number 5. Right? So let's put it into 7, then 5. Okay, so that is what it looks like after I've inserted the wires. Okay, right. So sorry if the wires are getting in the way. So you should be able to see. Right. Next, we need to provide the voltage source. So 5 volts over to that, and then ground. Okay. This will go to the servo motor, but we will need 2 more female to male wires. So just let me just grab that and get back. Goodness. So actually, we just need 2 male to male, so that should be fine. Okay, let me see if I can. Okay, we can take the book aside. And then we will need the wires for voltage and ground. Okay, so we'll connect the servo in a moment. For now, let's put in the code for the proximity sensor. Okay, so I'm just going to copy the code into our program, or the program that I'm creating. So actually, there are no libraries that are required, so it should be quite straightforward. One of the things that's good about working with existing code is that all you need to do is just copy it in, see it run, and then figure out how to customize it later on. So that's what I always like to do, because as much as I've been doing this for a couple of years, honestly, sometimes I don't remember everything. So it's good to always refer back. Right? Okay, so what I did here is I've set up the ping pin as well as the trigger pin, I believe, the echo pin and the trigger pin. So let's see. Let's see what it says. Okay, so basically what it says here in the guidebook, right, is that um, the ultrasonic sensors provide a measurement of time it takes for sound to bounce off an object. As obviously that's what ultrasonic is. Like the ping sound pulse is generated when the ping pin level goes high for 2 microseconds. So when the ping pin goes high, it basically sends out a signal, a pulse, and then it waits for an amount of time that it comes back. So based on the amount of time it comes back, the sound travel, the distance of the sound travel, that's how you actually measure the distance. All right. Okay. So let's do the continue with the coding. So I'm basically just going to copy the code anyway, since they've already provided it. Right. So this ping function basically it has a long to measure duration, to capture a duration, and the centimeter, which is the distance. Okay, setting the trigger pin to output and writing low and then writing high and low again. So this is basically sending the trigger, the sound, right? Ping the sound. So this pulse in, I would believe the pulse in is to read the signal bouncing back. So I'm just going to verify and make sure that I'm correct. Yeah, so the pulse in function will be used to measure the duration. All right, so the speed of sound is 340 meters per second, which is about 29 microseconds per centimeter. Right, so the formula for the distance of the round trip, let's just put it here. Formula. Distance. All right, so that is that. Okay, so next thing, um, okay, so this long microseconds to centimeters method basically takes the number of microseconds for the uh, pulse, all right, and then basically how much time it took for the pulse to come back, bounce back, and then divide that by 29, and then by 2. Yeah, because you need to measure the one-way distance, right? So divide by 2. Okay, so basically with that, you'll be able to get the number of centimeters. Let's say if cm is smaller than or equals to 10 centimeters, okay, we will want the servo to open the box. If not, we'll close it. Okay. Hmm. Okay, so another thing about working in C++, you should probably remember if you are putting your methods, custom methods, after your loop and your setup, you will need to have a what we call prototype method, right? Just without this prototype, they won't know that the method existed. Yeah. Now I have to say that even though I spent a lot of years as a software engineer, and I'm pretty good when it comes to application knowledge and applying what I learned. I'm not very good with theory. I don't explain theory very well. It's kind of like if you want me to show you how something is done, I can show you how it's done. But when it comes to really explaining it, I sort of don't really like theoretical way. I like to use examples to explain certain concepts. So basically, yeah, if there's anything in my videos, any concepts that I explained that was inaccurate, just share with me, in the comments below. Just give me the feedback so that I will know, and next time around, I will remember it. But yeah, I'm basically not your typical academical kind of guy. I'm more of a practical hacker, right? So hands-on hacker, yeah. Okay, so let's save. Okay, so it's great. Now we're gonna uh, compile it and download it to the program. Now we can finally attach our servo motor. Okay, let me just switch the screen over. Okay, so we are going to connect. In this case, my blue is ground, purple is ground, sorry, blue is voltage. And then we're going to connect the okay. So basically, nothing is going to happen right now because obviously, the proximity. I don't know. Will it happen? Let's give it a try. Oh yes, it works. Let's remove, and it closes. Awesome. Okay, so if there's nothing in front of it, it should not open. So let's put it down, and I'm going to try putting it in front. So let's say I decide to put it at the front. Okay, because I have my hand there. Okay, so it should close. Now the one thing that I haven't figured out is how to actually close the box fully. I thought using nylon strings as well, but yeah. So anyway, I know this might be a little bit blurry for you guys. So okay, so if I were to put my hand here, it will open the box. All right, so I'm just going to do it again. You open the box. and then it will close. And voila, it works. So we actually got a working example tonight. That is great. Definitely productive. And basically, in this session, you sort of, okay, I guess that was. So basically, in this session, we sort of figure out how to make use of the servo motor as well as the proximity center that actually comes from the ultimate starter kit for Arduino. So honestly, everything that comes with the kit, you've seen it here, as well as, of course, with the breadboard. The breadboard that you see behind over here comes with the ultimate starter kit, right? But I was using it for a different project yesterday, a different lab showcase. All right, so everything you see here comes right out of the kit, so you don't need to buy anything else, and you just need to be a little bit creative, and that's all, right? So with that, I really appreciate your time watching this video. Let me know if you have any thoughts about what you can do with a automated box opener. I mean, the idea that I have is a parcel receiver, right? So a delivery guy comes, and then he signals the receiver. Maybe I'm not home, I'm outside. And then, I would receive a notification and I would have a mobile app maybe, and then something that I can communicate with my home web server, maybe a ESP32 home server, or even Raspberry Pi. Then from there, it will send the Wi-Fi signal over to the ESP82 ESP8266 module, or even ESP32. And then that would actually control everything that you see here. So that is one of the ideas that I have that could be useful in the future. It could be a possible use case. But yeah, if you have any interesting ideas, or any ideas that is not related to this, but you think is something that we can showcase and we can work on in the future lab sessions, do let me know. Ultimately, I want to work with the kits that are available from Adept Studio. Now, there would be other brands that we want to take on in the future months, maybe July, August. Brands like Seed Studio, DF Robot, Sunfounder, and so on. And from those kits itself, what sort of projects can we create? So the main focus is not to uh, buy anything else. So the key thing is that, hey, with all these kits that they have, say they send me all the product samples, right? All the different kits. With all the kits combined, or with each individual kit itself and the parts that are available in those kits, what can we create, that is beyond the lessons that are available with that starter kit itself, right? So that is what I want to do and what I want to explore, and also to help you guys get to know, like why these kits are really that good. And basically that's the whole idea, right? So thank you very much, guys. Note that there's no lab session next week. Next week is sort of a break, all right? And then I'll be back the following week with a lot more updates, all right? So good night wherever you are, or good afternoon, good morning. So thank you for watching, guys. All right, see you next time. Bye.